Hi, Assalamualaikum, and a very good day to everyone. So today we're gonna do a lab session on pattern recognition, which is for problem 1 on PCA and another one on KNN, K nearest neighbor. In PCA is part of the pattern recognition and also multivariate analysis, and on problem 2 is KNN on the supervised method. So both method kita buat assignment lah. Okay, ini adalah assignment 3 kita, and for this assignment you have to install NumXL first. I already give you the link in e-learning. You have to download it, install, and get the license, the free license, and from there we learn as long as we learn how to solve the problem given using Excel, and also add on NumXL. Okay, the NumXL is used for to solve problem 1. And the KNN will be done using Excel. Okay, so after you have installed NumXL, you have to open Excel, and from there you can see the NumXL tab. Alright, so this is the Excel that I've opened, and from here, if you can see this on top of your ribbon, you can see NumXL tab. Okay, so that shows that you already installed NumXL and it's already added into your Excel. So when you open your document on your assignment, you have this problem 1 and also problem 2. Okay, problem 1 is the PCA analysis. Problem is given as you have a analysis for 27 elements, and you want to divide into 6 groups according to their position in the periodic table together with 5 physical properties. So if you actually want to know if there is any natural groupings within this elements or the sample dia ialah element in the group. So group 1 is the apa tu group yang kita dah tahu lah kan, lithium 1, natrium 1, and so on, and this 1, 2, 3, 4, 5, okay, melting point, boiling point, density, oxidation, and electronegativity is the features or also the variables for this session. So as the group ni ia indicator lah, kita nak tengok dapat tak grouping ni balik bila kita buat natural grouping dalam PCA nanti. Dan di bawah ni adalah all the steps that you have to do to do the groupings ataupun to do the PCA. So steps here ialah, first you have to standardize your 5 variables using the population rather than standard deviation. Okay, so arahan pertama ialah you have to standardize the 5 variables using the population standard deviation. So you have to find the based on the 5 variables, you have to standardize using standard deviation. So how to do that? First, you have to transfer all this data, element, group, melting, boiling, density, oxidation, and electronegativity into the Excel. Kita highlightkan all these things. Okay, sampai sini je. Copy, Ctrl C as copy, and then we paste it here. Start dengan 1 saya buat besar ni supaya nampak. Alright, then we can see that there is all the information that has been transferred. Okay, so all these things, and you have to standardize the 5 variables using standard deviation. So kalau standard deviation, as what we've learned in simple calibration, in the simple calibration method, the thing is in simple calibration method, standard deviation should be calculate x1 tolak mean, x2 tolak mean kan, satu-satu. Tapi di dalam Excel, you can use formulas, this one, formulas, insert function, the function into here. So to calculate standard deviation, you first need mean, and then you need also your standard deviation. Okay, you can see that it looks like this, standard deviation, mean. Okay, you ignore this part because this is just an indicator. Kalau something yang awak tak tahu, awak you just leave it. But this one is actually indicator yang kita dah tahu, yang kita nak tengok boleh tak dia ikut grouping yang ni. So what is mean? Mean is, dia kata apa? Population mean. So in Excel, you can search for population mean using function. Untuk guna function, you can either click formulas and insert function, and you can look or search for mean, MEAN. Mean dalam ni dipanggil average. Okay, and double click there, you can see returns the average, means that can be number name. Okay, sekejap ya. Kita undo. Okay, sama dengan cara dia ialah kita insert and then look average. Okay, and then from here you can read. If you don't understand, this one is not apply only for this calculation. Okay, so I'm not sure whether you know how to use insert function, but insert function can actually first be search, boleh melalui searching, and then bila awak tak confirm what does this average means, you can look at here as the definition. Average, return the average of its argument, arithmetic mean. Okay, so ni mean yang kita nak, which can be numbers or names, arrays or reference that contain numbers. Okay, you click here and then you click OK, and it will ask you to select numbers. Okay, kalau klik sini, okay, klik sini, okay. Okay. So bila awak klik balik dekat average ni, bila klik balik kat nombor ni, you can see the average over here. This, kalau saya boleh besarkan, tak boleh. Okay, never mind. Okay, you can see that it's from C2 to C28. In Excel, it's easy because when you click here and you click at this cell, we call it a cell, you can see that dia start daripada sini. Okay, kalau start daripada sini, dia C1. Kadang-kadang dia auto, but you still have to make sure that it's the correct range that you want. Okay, so ni daripada sini pergi sini, C1 sehingga 28. Okay, betul, and then you enter. So the mean is 6, 7, 678.4. And then you have boiling point, also the same thing. Okay, in Excel, first you do, if you want to repeat the same thing again and again, what you can do is you copy this function. When you copy here, Ctrl C, it copy the function, the whole function, not the number tau, the function. And then you paste, sebab kat sini semua dia punya calculation dia sama kan, daripada sel C2 sampai sel C28. So we just paste it here. Okay, salah, kita pastekan semua sekali, highlight kat semua dan kita paste. So semua dapat nombor mean. What that is the mean, average, mean. Okay, and then you get the standard deviation. So how to get the standard deviation? You klik sama dengan, boleh cari macam tadi, enter, ataupun another cara is you klik sama dengan and you just type ST for standard deviation kan. So and then you can see list of standard deviation, type of standard deviation. One is standardized, standard, SDEP, PSA, dan seterusnya kan. So how we know we choose the correct one? We read at the definition over here. Kat sini tulis calculate standard deviation based on the entire population. Kalau ini S, estimate standard deviation based on a example, based on a sample. Okay, so mestilah kita nak cari P sebab dia kata population. So you double click there, and then standard deviation you highlight. Kalau tadi dia bagi sel kan, kalau kita pergi dekat insert function, tapi kalau dengan sama dengan saja, we have to highlight where we want and then tutup, close the bracket, enter. Then we get the standard deviation. Okay, the same thing we want to apply to other variables. So we copy here and we paste it, highlight and paste. Now you got mean and standard deviation, and your next part is to create a standardized type of sample, standardized type of features, variables. You have to standardize the variables. Okay, so first is the original rename. Original data. Okay, boleh rename dia punya tab, original data dekat bawah ni, and this can rename as standardized. Okay. First, you copy all these headings and headings and also the elements and grouping. Okay, kenapa saya buat begini? Sebab the element, these are the one that is constant, and the one that changing are this value, the value of the observation yang kita nak change, or the value of the variables. Okay, so now we want to change this data 453, 461 kepada a new data. This method is called pre-processing. Okay, why does we do the pre-processing? Actually, pre-processing ada banyak method. The tujuan kita buat pre-processing adalah untuk mendapatkan sampel yang setara. So macam ni kan kita ada terlampau besar, and then bukan terlampau besar, yang sederhana, and then terlampau besar 1000, and terlampau kecil 0.9. So dia punya nilai tu tak sekata. So kita kena ada satu center. That's why based on the standard deviation, mean ialah average, and then based on the average and the deviation tu adalah beza dia lah, beza from that mean. Based on that we do standardization. Okay, and then from there we do standardization. So what does standardize mean? Kita tengok standardization can be done using using apa? Can be done using formula juga, function. So kita tak sama dengan, and we place standardized. So standardized, what does standardized means? It returns a normalized value from distribution characterized by a mean and standard deviation. Maksudnya daripada mean dengan standard deviation, kita dapat standardized value. Okay, nanti awak tengok nilai untuk yang original data dengan standardized data will be different. So click standardize, double click. Okay, if you are not sure, you can click yang biru ni untuk tengok definition of standardized. Dia akan terus pergi kepada online support like this one. Dia akan tunjuklah apa maksud standardized, description, and then equation dia. Besarkan sedikit. The equation, this equation is U. So this to confirm you what it is lah. Okay, anyway. So anything, kalau any function and you are not sure, you can quickly just check for the definition. Alright, then you get the standardized, kan dia ada bracket, or automatic ada bracket. So apa maklumat yang dia perlukan? Dia perlukan X, mean, and also standard deviation. Okay, mean dengan standard deviation kita dah generate just now. That's why saya buat mean dengan standard deviation dulu. Sebab keperluan standardized adalah you have to have X. X is the original data, mean, and also standard deviation. Then what you do is, dia kena bezakan dengan comma kan. So you get this original data dengan X kan. So ambil X, and then comma, and then mean. So this is mean. Okay, and then comma, and then last kali standard deviation. And deviation of this value the variable punya value. Dan kita tutup. Alright, so when we have confirmed with this, we place enter. Kenapa? Kenapa dia buat standardized? Dia sepatutnya original data. So, okay, sekali lagi. With this standardized, we click the data over here as mean, comma. Lepas tu, betul. Salah. Okay, again. Okay, with the standardized method, we have to put equal to, and we put standardized. So from here, this is the definition, X, mean, and standard deviation. So to get X, you go to the original data, X, comma, and then mean. Kat atas ni ialah dia punya cell that we are using. X is that, and then kita akan guna mean, this data, C29, and then comma, and also standard deviation. Klik kat standard deviation, and then tutup kurungan, enter. So we get negative 0.3823, and so on. Right, it's a small number. Good. Now we have 1. So we do another one. We copy this because it's the same value kan. Dia akan ikut the next one. So copy and we paste. So dapatlah all the standardized. Okay. Now this happens. So why this happen? This is because you have to make sure that what cell is this, in this formula, sama dengan is a formula, in this formula betul tak data cell yang kita gunakan. So to confirm this, we click data, and then klik dekat atas ni, dekat function, function of the cell, standardized, origin data, C3, C30, C31, we go here. Escape. Okay. click here and then you go, tak boleh juga. Okay, we click here, go to original data, boleh juga. Okay, yalah. So we click here and then we see the number original data ni kat atas ya, tengok yang kat bahagian atas ini, and at the same time you go to the next cell. Okay, ni first cell which is the original data yang kita dah buat dan dapat nombor. Yang the second one tak dapat nombor. Okay, kita tengok kenapa. Okay, the first one original data is C2, the second one is C3. Okay, betul, merujuk kepada C3. And then original data pula, and then C30 is the mean kan, tapi dalam ni it's not mean, dalam ni it's not mean, it's not apa, mean ialah mean ialah C29, so salah. Tengok yang ni original data C30. We need actually C29. And then escape original data yang original data. Yang apa? The third part is what? Standard deviation. It's C31. Yang ni pula C30. Okay, kenapa C30? Kenapa C30? Dia sepatutnya C30 tapi dia jadi C31. So what you can do is there's another function that maintain the data as a constant, maksudnya pemalar. So sekarang kita tahu the first part X will change, maksudnya C2, C3, C4, C5. Tetapi the mean and also standard deviation will not change. So in Excel, kalau data tu tak adalah pemalar ataupun tak boleh tak mau ditukarkan, so what you do is you change this original data over here, this cell over here kepada $sign pada nombor, pada huruf tu saja, huruf sel tersebut. So dekat atas ni saya tulis sebagai salah. Bukan yang ni. Okay. Kita tak buat kat bawah kita buat yang kat atas, yang asal-asal ni, original function yang kita copy tu. Tu kita letak $C$. Kita letak $C$. And then another one, yang kedua tu adalah standard deviation and it should be constant, also $C$. Okay. Now we copy this and we paste to all. Now we get the value. Okay, kalau awak tengok kan, if you run through from top to bottom, you can see that the cell for X will change daripada C2, C3, C4 dan seterusnya. Tetapi for original data, for mean and also standard deviation, it's not changing. C$29, $C$29 tu dia tak berubah. Okay. Dollar ni awak kena tulis dekat bahagian sini tau. Awak bukan tulis dekat tempat lain. Maksudnya it will not change if you write other places. Dia kena pergi dekat original function kita lah, dekat sini, rumus kita dekat sini kita letak. So dia pun, lepas tu kita pun dah dapat satu standardized. Okay, then after that we use this one to complete. We copy this function into here. Tengok betul tak dia gunakan. Then you check again lah. Okay, yang ni C29 as the C29 as the mean and C30 as the mean. So mean dia ialah D29 dan standard deviation ialah D30. So what you have to do is you change this change the data as D30 29 dan D30. Sebab min dia ialah supposed to be a boiling point punya min kan, bukan melting point. Tadi sebab dia pemalar, so dia akan ambil juga nilai yang C tadi. So we don't want that. We change directly over here as D. And then data X dia adalah D2, betul. Sebab dia punya cell dia adalah dekat column D. D2. D2 is the first one. So it's correct. And then this one also sama. Ni E. So kita change juga ni sebagai E. And then E as pemalar. Enter. Okay, lepas tukar kena enter. Dia tak boleh pergi tempat lain, nanti dia akan tukar balik. Okay, then kita tukar sebagai F. F and G. Now we already got our standardized data for lithium. Okay, so nanti awak kena buat semula daripada sini sampai bawah ni. Penuhkan ini awak dah pandai. Okay, penuhkan sendiri. And then ini pula bahagian melting point ni, you can see when we've complete with standardization, the value doesn't change much. So from negative 0.3 within 0.3 sampai 1 macam tu, positif negatif. So dia very small data, sama juga dengan boiling point, density, oxidation number and electronegativity. So that's why standardization or pre-processing is done before we apply this value into our PCA later. So saya pun dah selesai do the standardization. If you can see here, it's already completed. Melting, boiling, density, oxidation number and electronegativity. Penuh Okay, good. So we've done the first task and you have to answer this. Why is pre-processing necessary to obtain sensible result? In this case, answer it either by reading or do some search in the internet. And then the second task is to calculate the scores, values, loading and variance of the first two pieces of the standardized data. So maksudnya sekarang ialah waktu untuk kita convert lah from this standardized data yang ada kepada principal components to the new exist. If you still remember the PCs. Okay, and based on the PC, we'll get the scores, loadings and variance, also eigenvalue. But this software doesn't report on the eigenvalue but only on the variance. So now we go back to the Excel, start a new clean sheet, label it as exercise 1, question 2, and then you just put your cursor into cell A1. Then you go on the top of this ribbon, click NumXL and click PCA. Go on the PCA, you'll have this window. On general, click input data. So now you go to the Q1 standardized, the standardized data, and highlight all the data like so. Include the label of the variables, so you can get the label included, and output range is the output cell, which is A1 on sheet exercise 1 Q2. And then go to option, untick standardized input, because we already done the standardization. If you don't want to do any standardization, then if your data wasn't being pre-processed or standardized, you can click here, but we already done that, so we skip standardized input and focus on the principal component, tick all the box and untick the input variable output. Okay, because we don't do this, we only do the principal component. And on missing value, click on the remove observation from X and Y and click OK. So now we've got all the principal component result from your data. Right, so I would like to explain one by one what does this means. So the variance is the captured or explained by principal component factor. I'll just make it bigger. And so we have the variance between each of the principal component. If we total up the principal component or the values of this variance, it become 5, or means that total of variables that we have is 5. Another thing is proportion. Proportion is a percent of the total variance captured in the principal component. So this is the difference or the information observed by principal component 1, principal component 2, 3, 4 and 5. Alright, and then based on this, we can convert it into percentage, which is 65%, 22%, 10%, 3%, and also 1%. If you total this up, you can see that it's 1, so about 100, actually 100% lah. And cumulative proportion is the principal component when we add up. So 64.8% plus 0.65 plus 0.22 equals to 86.7%. This is in points, and you can convert that into percentage, and it's actually the additional or the cumulative of 64 and 0.8 and 0.22, 22%. PC1 and PC2 becomes 86.7%, and then this is the total of PC1, 2 and 3 becomes 96%, 99 and 100. So what you get information from here is how much of the information can we extract based on the principal component. So principal component plus principal component 1 plus principal component 2 becomes 86.7%. And if we plot 3 dimension, which is principal component 1, 2 and 3, we got 96.3% and so on. Now we go for loadings. So loadings represents your variables, right? So these are the variables, that's why I include all the labels, so they can just put it here, the variables, and we'll have the representation of each variables based on PC1, 2, 3, 4 and 5. So here are the numbers. And on values is actually the samples. I'll just add a rename. Over here, which is the loading. So values is the loadings, and loading is all your samples. These are all your samples. This column represents your samples. So each row represents one sample. Sample 1, sample 2, 3 and 4. And these are the loading for the scores, If we go to the bottom part of the loadings, there will be a value table, which is actually the score. So what does value means? It's a score. It is the computed values for each principal component. So each of the principal component will be represented by each value. And value means this part is all the samples. Sample 1, sample 2, sample 3 and so on. According to the one that you've done previously. And then this is the principal component 1, which is the new axis for 1 in the new plot for 1, PC1 for scores. This is for PC2, PC3, 4, 5, and so on. Actually, the number of PC also represents the number of variables. So if you have a number of number of variables like 100, so possibility to have one possibility, the maximum possibility of a principal component is up to 100. But of course, you won't go to 100, right? You just at least go 1, 2, 3, 4, 5 like that. Not really more than 10 or not really more than 5. So here are the values or the scores, and to make things easier and much more better representation, you go to this standardized data and just include the group element and group. No, just include the li. You go here, copy all the samples and paste it here. Alright, so now you know this represents li, this represents na, and so on. Okay, good. Now you've got your principal component report. The question again is the scores, values, loading, and variance of the first two principal component of the standardized data. So it needs only 2, so you can just highlight 2. Like so. And then, of course, I know what this means, right? So you have to also put some notes at the side to mention what does it means. Okay, not comment, but a text box. Okay, text box. You just click on up here, insert or text box, and then write down PC1 and PC2 is highlighted in green. Okay. It doesn't stop there because there's more. So it asks for what is the sum. So you have to answer this in this box that you have created. Okay, answer this in the box. What is the sum of the first two variants? So jumlah variant, dua variant, and what is the proportion or the percentage of the overall variety do they represent? Okay, so jumlah two variants is ni campur ni lah, and then proportion total you can represent by points or percentage. Tapi kat sini saya tulis percentage kan, so you have to report by percentage. Okay, that is answer number 2. Okay, now we go to number 3. Plot a graph of the scores of PC2 versus PC1, labeling the points, comments on the grouping in the score plot. Okay, so focus on score plot, and you take PC2 and PC1 plot together. Okay, this is also called as biplot. Okay, add new sheet, rename as exercise 1, question 3. So you just copy your values or your score, take the first two and put it here. So based on this, you need to just remove this color. Normal. Okay, let's remove the color. Just remove the color, the background color, and then you'll get this plot, and you can plot PC1 versus PC2. Just highlight it and plot. To plot, you go to Insert, Charts, and just do a scatter plot. Okay, good. And then the title change to plot. Okay, from here you can add the axis to make it better, which one is PC1 and which one is PC2, by clicking on the format, chart design, and choose the best format. We want the one which have layout. Oh yes, format and the layout. Yeah. You just remove this label because it's not necessary, and axis, label the axis as PC1. How many percent just now? 64.8%. And PC2 represented by 22%. %. Okay, good. Now you have your own score plot, but you don't know which one of it is which. So let's answer the plot a graph of the scores, PC2 versus PC1, labeling the points. So you have to label the points, comment on the grouping in the score plot. Okay, to label the points, what you have to do first is to show all the data inside here. Add data label. Okay, so these are all the data, and then you go to here, to each of the, when you hover ataupun letak awak punya mouse dekat points, awak boleh baca dia punya koordinat dekat bawah ni, -2 and 2.85. So -2.08 and 2.85, -2.08 and 2.85 is F. So what you do is you label this as F. You get what I mean? That's what labeling means. So means that this we do manually, because in the real program like scrambler or eigenvector, eigen value punya software, semua dia already label. Tapi kita buat ni sebab kita nak experience ourselves how to label, how to standardize, kenapa kena buat, macam tu lah. Sebab tu kita buat satu-satu. Okay, kalau label ni kan sebenarnya kita boleh ubah. Kalau dia bertindih, kita boleh ubah. Terutama yang kat sini lah kan. Okay, go to that point and check the point as minus 2.01, 2.08. Minus 2.01, 2.08. So CL. Yang ni, sekejap yang ni kan. Ni. Kalau tak tahu nombor dia betul ke tak, go situ. Ada tunjuk lagi. So ini adalah CL. You just label it one by one until you're done. Okay, banyak kerja sikit lah. Tapi yalah, saya dah tunjukkan tutorial. So you just have to do the homework. CL and so on. Just do one by one until you've complete everything. Now I'm done with the labeling of each of the points based on the elements. You can comment on the grouping of each of the elements. Does it stick together, or does it, like this one, stick together, further apart? And also based on the groupings, you can include groupings over here. Grouping on this one group. Okay, you can just copy this, copy and paste over here. You can paste normal, or you can just paste values. Okay, I'll just paste it normal, like that. Not grouping, group. And you can compare this, each of the grouping. To make things more interesting, you can even, or much more make sense, you can even color it based on the grouping. And then you can see what's the effect of the grouping towards the elements. Okay, for example, I'll do this fluorine, chlorine, bromine, bromine. Okay, group 3 as yellow, and then group 2 as blue, group 1 as green, and so on. So from there, just group the element, like fluorine is 3. So what you have to do is you go make it into a bigger besarkan lagi, and then supaya lagi senang nak klik. Ini dia klik semua tau, tapi kalau klik satu betul-betul kat bulat ni, yang lain semua tak klik sekali ataupun tak highlight sekali. So itu maksudnya awak klik hanya pada F, and then klik right click and you put, tadi kita buat warna kuning, letak kuning, outline pun kuning lah, ataupun no outline lah, senang tak payah fikir kan. Okay, kena outline. Okay, why not you just put black as the outline, baru nampak. Okay, tak apalah, biar je lah warna biru, tak payah outline. So we'll do one by one with the other group. Yellow, and this one yellow. Oops, no. Okay, because you highlight other things tu, nampak ada dua kan. Tu kena hati-hati lah part ni, betul tengah kot. Lepas kita buat yang lain dulu. Dua kali klik, dia akan okay, dia akan go to that point. Okay, so 3, kita tengok 3 ada berapa? 1, 2, 3, 4. Ni warna biru is BE. Okay, tu dah okay. So BE, mana BE? Ada. Kita buat warna biru. Besarkan dulu. Okay, double klik. Biru. Ni kok biru je? Sama lah. So tak payah ubah. Okay, sama biru. Biru ni tak payah ubah. Buat LI pula. LI warna hijau. Warna hijau. Okay. Dan seterusnya lah. Buat sampai habis. Okay, so this is the result after I've done coloring by the group. To make it easy, I just do color coding for each of the group and then color the elements based on the group. You can see over here, there's about 6 group. I'm following the same group. And then what we do is, based on this questions, you have to comment on the grouping in the score plot. So maksudnya kat sini awak komen lah sikit. Apa maksud komen dengan apa tu kat bawah ni, tambahkan, insert comment, letak enter comment pula. Insert text box, dan tulislah kat bawah comment. So tulislah apa, basically the grouping is what, can you find natural grouping or not, and so on. Apa-apalah komen dalam ni, and then I'll see how you think about this plot, score plot, how you explain, how you think about its forming. Is it good enough or is it not good enough? Is there any outliers? Okay, do you think if there is any outliers in here? So you just comment. And that's it for question 3. Now we move on to the question 4, which is a plot graph of the loading. Okay, tadi score, sekarang loading pula, of PC2 versus PC1, labeling the points, which variables cluster together and which appears to behave differently. So nanti kita akan tengok, tadi kita tengok behavior of the sample itself, grouping of the sample, and now we are looking at the grouping of the grouping of the variables or the features. And then you check for hence which physical properties mainly account for PC2, yang memberi kesan kepada formation of PC2. Dalam PC2 siapa yang bagi impact. Okay, tak apa, kita try. So now we go back to this Excel file, add one more, which is, and label it, rename it as exercise 1 question 4. Okay, and then what you do is you include the loading. Okay, the loading is here and it already dah siap label pun. Okay, so what you do is you copy this, klik kanan, copy, and then paste it in exercise 1 question 4. And okay, yang ni sebab dia melibatkan rumus, jadi usually kalau buat macam ni mesti rumus dia tak jadilah kan. So what you do is usually you just paste as value. So bila paste as value means that awak hanya ambil value dia saja. Kalau awak tengok di sini, nombor saja yang ada, bukan rumus atau function seperti dalam sini. Kat sini kalau tengok, okay, atas ni ialah function. Okay, kalau kita kembali kepada question 4, dia hanya nombor saja. So good. Now you have this loading and you have to plot PC1 versus PC2. How do you do it? If you just select this, the whole thing, and then you plot a scatter plot of PC1, PC2. Nanti kita label. Okay. Just plot a scatter plot. Okay. So they assume yang PC1 is X, PC2 ialah Y. So if you have that, then put in your title. Okay. And go to chart design, quick layout, and make sure that you have the axis title. Okay, ni paling mudah, layout 1. Alright, with that, because you know this is just a plot, scatter plot, you remove the series 1. Okay, then we have full plot, axis title. This is like just now, kita letak PC2 bracket berapa percentage, 21.9% and next is PC1 64.8%. Alright, good. Now, as usual, you just have to include the label, add data label. And like just now juga, kita tengok daripada koordinat dia tadi, 0.916435 ni ialah y-axis So y-axis ialah, this one is electronegativity. So we relabel it as the variables. Okay, and then this one 0.20. Okay, selesaikanlah semuanya. Plot. Okay, dah siap. Plot loading. Then answer the question, which variables cluster together and which appears to be differently, and then kenapa, hence which physical properties mainly account for PC2. Apa yang menyebabkan PC2 tu behave like that. Okay, now question 5, calculate the correlation matrix between each of the 5 fundamental parameters. Okay, correlation matrix ni very easy. You can just search in the YouTube how to do a correlation matrix using data analysis, and then between 5 fundamental parameters. So based on this parameter, kita nak do a correlation matrix, and then how does this relate to clustering on the loading plot. Okay, mudahnya macam ni lah. Just open a new sheet and then rename exercise 1 question 5, and then you just use this data analysis correlation. Okay. Alright, so kata correlation, the data should come from, kita dah buat sikit tadi kat question 4. Ambil, and then data, because the variables ada dekat belah kiri, and then grouping dia adalah begini. So kita ambil yang row, and then output range, kita nak letak output dekat mana, kat sini contohnya. And then kita highlight semua sekali tadi. Sekali lagi padam dulu. Kita highlightkan semua sekali, termasuklah tajuk label dia. But if you highlight the label, you have to click the label in first column. Now it looks like that. So means that awak dapat melting point di sini dan correlation. So the correlation means that how correlate between one variable to another variable. Boiling point dengan melting point berapa correlation. So correlation yang positif adalah yang ke atas lah, makin besar makin bertambah. Kalau yang negatif maksudnya makin besar makin berkurang correlation dia. So itulah, you have to decide lah yourself and comment on this correlation matrix. How does this relate to clustering in the loading plot? Macam mana loading plot ni terhasil based on this score plot. Okay, so you can have that. Okay, number 6 lagi another question, which is you have to remove the parameter that exhibit as high loading in PC2. Okay, siapa yang memberi kesan paling banyak dalam PC2? Apa yang paling pelik dalam PC2? And recalculate the scores using only 4 parameters. Okay, and then plot the scores, what do you observe and why. So means that awak kena remove kalau yang ni parameter dia. Okay, ada question 5 tadi kan. So kita ada parameter, all these 5 parameter ni, question 4 tadi ada 5 parameters. So based on this parameter, calculate the score using only 4 parameter. Okay, buang satu yang mana macam tak sama ataupun tak group together ke, buang satu and then tengok kembali the scores, plot the scores again. Okay, what do I mean by that? Means that you have to redo this part, principal component analysis part, but only using only highlighting 4 of this. Tak kisahlah ini ke macam ni ke, 1 2 3 4 ataupun the other way round, ikutlah. Tapi kalau yang tak nak tu nanti remove lah, remove, buang. So ambil yang 4 sahaja for example ya. Alright, so itu boleh buat sendiri. I hope you can finish this in a very short time, because I gave you a very detailed and comprehensive exercise tutorial. And then you have to remove. Okay, then you plot the scores as like this. You have to plot the scores as you've done previously. Yang ni. Okay, hari tu ni yang pertama kan. Okay, then compare yang plot score yang earlier and the new one with only 4 variables. And then kenapa? So kat sini nanti kat awal ni nanti ada grouping ke apa. So you comment on whether the grouping becomes better or not. Okay, so comment lah. Alright, so that is for problem number 1. So for problem number 2 is on supervised method, which is the simple KNN classification, and you have been given the 5 measurements on 16 sample in 2 classes A and B. So you already know the class, and these are the measurement and these are the sample number. And then you have to calculate 16 by 16 sample distance matrix by computing the Euclidean distance between each sample. So do you still remember Euclidean distance? Kalau tak ingat, boleh rujuk nota yang sebelum ni, tengok rumus dia macam mana, and calculate the 16 by 16 sample. So you open a new tab, name problem exercise 2 question 1. Okay, so from there you can calculate the 16 by 16 by computing Euclidean distance. You first just transfer all this data into Excel. Okay, once you got that, you buat exercise 2 saja ya. Sebab yang nanti kita akan gunakan bolehlah ini question 1 So kita kena buat Euclidean distance. Macam mana kita nak buat ni? So in a Euclidean distance, alright. Okay, just take this Euclidean distance macam mana? Okay, so this is sample 1. Kita macam mana kita nak transposekan dia? Kita ambil semua, copy and then transpose kat sini. Okay, transpose. And then kita paste kat sini juga. So we have this matrix. Okay, from this matrix, you calculate the Euclidean distance. So sama dengan berapa? Punca kuasa. Kalau ingat lagi Euclidean distance nota tadi tu, dia punya rumus adalah sebegini. Dan it's actually the distance of A and B. Kalau satu dengan 2, satu dengan 3, satu dengan 4 dan seterusnya. And then tolak kan. Lepas tu kuasa 2 tambah semua sekali dan punca kuasa 2 kan. So the easier so you have to find out how to do this in Excel using formula and function. You have to do a little bit a little bit of try and error lah. Rumus kena buat sendiri, dan kalau tak faham boleh tanya pada saya. Okay. Then after that you get this about this matrix. Then you get this matrix. Then after you get this matrix, you have answered question number 1. And then for question number 2, for each sample, list the classes of the 3 and 5 nearest neighbors using the distance matrix as a guide. So awak kena check all the distance again yang daripada matrix tu. List the classes of the 3 and 5 nearest neighbor. Maksudnya awak kena cari yang 3 paling dekat dengan 1, 3 paling dekat dengan 2, 3 paling dekat dengan 3, that's A. Yang part B pula 5 paling dekat dengan 1, 2, 3 dan seterusnya sampai 16. Okay, using the distance matrix as a guide. Okay, so untuk mudah awak boleh letakkan warna lah macam ni kan. Letak warna merah sebagai the 3 nearest neighbor and red plus green as the 5 nearest neighbor. Sebab the 3 tu 5 tu include yang 3 tadi kan, cuma bukan saya tambah 2. Okay, you've done with number 2 and number 3. Verify that most samples belong to their proposed class using principal component analysis method. So what you have to do is, after that you have to list out your, lepas awak colorkan, awak list dulu. Okay, that is question number 2. List down the sample. Okay, sample 1, sample 1 pula. Sample that have 3 nearest neighbor, sample that have 5 nearest neighbor. And then verify that most sample belong to their proposed class using principal component analysis method. Okay, verify guna principal component analysis. However, you first have to calculate the frequency of each of the grouping. Contohnya kat sini, okay, sample 1 kelas dia A kan, and then dia nearest neighbor ialah 3, 4, 6. 3, 4, 6 ialah group A, so saya colorkan merah lah. And then 2, 3 dan seterusnya saya colorkan mengikut yang nearest neighbor tu ikut dia punya kelas, dan tengok sama ada dia dekat dengan kelas A ataupun dia dekat dengan kelas B. This is for verification and look at the frequency. Compare lah 3 nearest neighbor and also 5 nearest neighbor. And after that, you check you check your classification, the one that you've done this with the principal component. And this principal component analysis should start with using variables from the raw data. So ini variables of the raw data, the sample, and these are the variable 1, 2, 3, 4, 5, and class. Okay, so use this data as the variables. This is from the original data, and then do a principal component, about 3 principal component, and then just compare, plot the graph, and then compare it with the one that we've calculate the frequency from here manually. So that's how we verify it lah. Okay, so maksudnya yang the first one ni, ini yang kita buat dan kita kelaskan, dan actually kat sini pun dah nampak yang mana yang misclassified. But to verify a second method ialah menggunakan principal component analysis. And then give your comment lah, janganlah tunjuk saja, because I don't know what you are doing. Alright, so that's it from for the lab from me. So I hope you can do the rest of the lab, and even though it's a short time, I think it's manageable because I already done show you how to do it. Only that problem 2, you have to solve some of it because I already teach how to use constant and everything. So sampai sini saja dahulu. Okay, bye. Assalamualaikum.